Hello, everyone. Hope you all are having a great week. So before we get into things, just a reminder that you do have a lecture exam this week. So good luck on that if you haven't taken it yet. And if you've already taken it, when you're watching this video, hopefully you all did great. We've got a little bit on the longer side of PowerPoint this week for lab. Then we'll very quickly touch on one of the new things you'll be doing in Google Earth Pro, and then we'll run through what's in the lab very quickly. And hopefully it should be a straightforward week. So let's hop over into the PowerPoint. All right. Sorry. So lab 10 is on coastal processes and landforms. So first, we're going to talk a little bit about erosional processes and features on the coasts. So important to know, when waves approach a coastline and the shallower waters around it, these waves may be refracted or deflected, as you can see in this image on the right. And when they're refracted, this may focus their energy on headlands or pieces of the coastline protruding into the water, which this is a headland here. And in turn, that refraction dissipates the wave energy, and over time, the headlands will be eroded away, straightening the shoreline. So in terms of some prominent wave eroding landforms, I'm not sure if you all have covered these in lecture or not, but you can see of the important ones for this lab, a stack here is sort of a rock out in the ocean. You can see an arch right here, a cliffed headland, a marine terrace, a sea cave, a notch is sort of this indent in the wall, and an abrasion platform is this relatively smooth slope that comes out like you might walk on a beach. Make sure you know most of those and have a general idea what they are. On the other hand, in terms of depositional processes and features on coasts, littoral drift or longshore sediment transport is the movement of material parallel to the shore by currents that are parallel to the coast, called littoral currents or longshore currents. Littoral drift creates spits, tombolos, and baymouth bars, which you can see in this image over here on the right. So a spit is sort of this curved bit here. A tombolo is a usually thin sort of line of sand that connects an island of some kind or maybe a stack to the shore. And then a baymouth bar you can see here is these sort of bits that come out into the bay. Know those three, know what they look like, be able to identify them. And it's also worth noting for depositional processes that seasonal differences cause beaches to tend to be enlarged during the summer and eroded away during the winter. You'll read a little bit more about that in the lab materials itself. Further, you have tidal formed features. So we've been talking about sort of wave form features so far, but you also have tidal form features like tidal flats, estuaries, and inlets. You can see a picture of an inlet here, and we'll talk a little bit more about the parts of an inlet on the next slide, but get a good idea of what that looks like. And an inlet is a gap in the barrier island. So you can see this barrier island here. And now thinking about that, around a barrier island and an inlet, you have a flood tidal delta and an ebb tidal delta. Flood tidal deltas are on the landward side of the inlet, and they're created by incoming tides. Ebb tidal delta are on the seaward side, and they're created by outgoing tides or rivers flooding from the mainland. Also in these sorts of barrier island complexes, you have beach dune complexes. So beach construction occurs through wave action on the seaward margin. So you can see this is where your beach would form. And dunes are formed by aeolian processes driven by offshore winds. You can see your dunes in this image here. And finally, washover fans, which you see here, are deposited by water and sediment that crosses or penetrates the beach dune complex. And if you go back and look at this picture, you can see a lot of those features here. And you'll be looking at them in the lab as well. Finally, we'll talk a little bit about tide versus wave-dominated coasts. So large tidal ranges tend to form wide bell-mouthed bays and numerous inlets and islands perpendicular to the shore. So you can see that here on the left. This would be a coastline primarily formed by tidal processes. On the other hand, strong winds and waves in the absence of strong tides tend to create longshore currents, which make barrier islands or broad, unbroken beaches parallel to the coastline. And you can see, on the other hand, here in sort of the Outer Banks of North Carolina, that's an example of an area created by mostly wave processes. So know the difference between those two and be able to sort of identify what one might look like over the other. And then finally, it's worth mentioning in terms of tide and wave dominated coasts, that when you think about the Southeast, we have both tide and wave dominated, and they sort of transition up the coastline. So here around like Savannah, Georgia, you have tide dominated coasts, whereas up here, like we were talking about with the Outer Banks of North Carolina, those are wave dominated coasts. That's all the information we need to cover for the PowerPoint. So we'll very quickly hop into Google Earth Pro to take another look at the only new thing. So the only new Google Earth Pro process you need to know for this week's lab is how to take an area. And I'll very, very briefly go over that. 1 second, I need to move this little zoom bar out of the way. So if you want to take the area, sort of like how we've taken length of lines and paths, you go here, you select polygon, you select whatever size you want to do of area and what units you want to perimeter, and then you just sort of click along. Let's say you want to take the area of this island here. You click along, you set points approximately. Let's say you messed one up and you put one here, and then you kept going. You can right click again or double click on Mac to undo a single point. And then let's say we finished up. So that's, it's close. So we can see here that this area has a perimeter of about 3 kilometers and an area of about 0.7 square kilometers. So you're going to be using that area taking and measuring process during the lab of polygons. All right, and so last, we'll hop over and take a quick look at the lab itself. 1 second. Okay, that should be good. So you'll read through, the lab goes into a little bit more depth than what I covered in the PowerPoint, so make sure you read through all of that. And then for the activity, again, you're going to be going to Google Earth Pro, and you're going to be looking at, I think, 5 different locations, some in the Southeast, but all around America. Maybe you'll even have been to a couple of them. You can see Washington here, Washington again, Sullivan's Island and Isle of Palms, Edisto Island, and then finally Sapelo Island in Georgia. You'll be doing and describing a few different coastal processes and landforms in each of these. Some of them are really interesting. I mean, they're all really interesting, of course, but I think you'll enjoy some of them. As always, make sure to take the quiz by this coming Sunday at 11:59 p.m. And it's important to note that if you haven't taken it yet, you do get 1 skip. One lab grade gets dropped. So if you want it to be a skip, keep that in mind. This is lab 10. There are 11 labs over the semester. So you might want to skip the next lab. You might want to skip this lab. I mean, I guess if you watch this video, maybe you don't want to skip this lab yet. But keep that in mind. Or if you already have a quiz grade you don't like or you want dropped, then maybe you want to do all the labs. But have a great week, everybody. Again, good luck on your exam, and I'll see you all next week.